Video we are going to see air conditioning. Myself, I'm Rajkumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Air conditioning is involve the controlling and maintaining the desirable temperature, humidity, velocity and direction of flow of air in a closed space. It is also carry out the filtering and cleaning of air. The applications of air conditioning. Air conditioning of house, hotel, theaters, etc. Hospital, operation theater, and intensive care units are air conditioned. For comfort of a passenger in cars, bus, train, ship, and aeroplanes, it becomes very essential in many industries like textile, food, printing, and machines, tools, etc. The terminology in air conditions. These are the properties of air. We should know. First of all, we are going to see the dry air. What is the meaning of dry air? So dry air is nothing but air without water vapor or moisture. Then moist air means it is a moisture of dry air and water vapor. Dry bulb temperature, actual temperature of a gas measured by a standard mercury thermometer. Wet bulb temperature means the temperature measured by a mercury thermometer when the bulb is covered by a wet cloth. Then saturation air, a mixture of dry air along with the maximum possible water vapor at dry bulb temperature. Then relative humidity, the ratio of the mass of water vapor in a given volume of air at a given temperature to the mass of water vapor present in the same volume under the same temperature of air when it is fully saturated. These are the terminology in air conditioning. Then requirements of comfort air conditioning. Due to the natural phenomenon of body heat disposal by evaporation of moisture from the human body and inflow of moisture from other sources, the humidity inside the room increases. The increased humidity causes difficulty in disposing of body heat. Also, our room temperature rises due to the heat dissipated from the human body and heat gains from light source and any other requirements. When the room temperature is high, it causes human discomfort. For human comfort, need a dry bulb temperature of 20 degree and 60% RH in the room. RH is nothing but relative humidity. Any air conditioning system should primarily be able to achieve the above set condition inside the room. Under normal living condition, a person inhales about 0.65 meter cube of oxygen and exhale about 0.2 meter cube of carbon dioxide in an hour. If the CO2 level in the room increases above 2%, it will cause human discomfort. Hence, the air conditioner should apply enough quantity of fresh air called ventilation air to be meet the oxygen requirements and maintaining the CO2 level within limits. Also, the conditioned air should have velocity in the range of 8 meter per minute to 14 meter per minute and be properly distributed inside the room for a feeling of comfort. Further requirements of comfort air conditioning demand that the conditioned air to be free from the dust, bacteria, odor and toxic gases. Then next we are going to see the different types of air conditioning system. First one, window air conditioning system. Second one, split air condition. Third one, central air condition. In which the first we are going to discuss about the window air conditioning system. Window air conditioning system is a simple air conditioning system without duct assembled inside a casing suitable for installation on windows or wall opening is called a window air conditioner. The unit consists of vapor compression refrigeration system, a double shaft motor, blower, fan, air filter, supply air grill, return air grill, fresh air damper, drain, tray and a control panel. These are the figure of window air conditioning system. In the window air conditioning system, the air is heated, which is generally followed by humidification. The figure shows the outside air flows through a damper and mixer up with the recirculating the air. The mixed air passes through a filter to remove dirty dust and other impurities. The air now passes through the preheat coil in order to prevent the possible freezing of water and to control the evaporation of water in the humidifier. After that, the air is made to pass through a reheat coil to bring the air to the desirable dry bulb temperature. Now the conditioned air is supplied to the conditioned space by a fan. From the conditioned space, a part of the used air is exhausted to atmosphere by exhaust fan or ventilator. The remaining part of the used air is again conditioned. You can see this figure. The outside air is sucked and made to mix with the recirculated air in order to make up for the loss of conditioned air through exhaust fan or ventilation from the conditioned space. This figure is a 3D view of the real image of the window air conditioning system. Then next we are going to see the split air conditioning system. It consists of two entirely different from the window air conditioning system. In terms of split of into two parts. One is indoor unit, another one is outdoor unit. Indoor unit consists of the evaporator, filter, evaporator fan and grill. They placed inside the room. The second part, it includes the condenser and condenser fan, compressor. This placed outside the room. The first parts include the first in between the wall is there. In between the it is separate from indoor unit and outdoor unit. In compressor, the main function of the compressor, it is used to compress the refrigerant. Then condenser coil is used to reject the heat from the refrigerant to the outside air. The condenser fan is used to air cooled condenser to help move the air molecules over the surface of the condenser coil. Condenser motor is located here. The motor usually has 2 or 3 speeds. Smaller unit may have only one speed of control and turn on or off simultaneously with the compressor. The indoor unit, the unit houses the evaporator coil or the cooling coil, the long blower and the filter. After passing from the expansion coil, the chilled freon fluid enters the cooling coil. Blower sucks the hot and humid and filter air from the room and it flow over the cooling coil. As the air passes over cooling coil, its temperature reduces drastically and also lost the excess moisture comfortable conditions of around 25 degree to 27 degrees centigrade. As per standard requirements, it can be mounted on the ceiling, wall or simply as an console unit on the floor. This is the our indoor unit. Then wall is there. In outdoor unit we have different parts. Outdoor unit having compressor, condenser and condenser motor. These are the units are in the outside of the wall. The main working principle of this split air conditioning system, the copper connecting pipes and electric wiring connection, the indoor unit to the outdoor unit of the split air conditioning system. The gas refrigerant is pumped from the outdoor condition coil and compressor through the connecting pipe to the indoor unit. A fan is then quickly distribute the cool air drawn across the unit evaporation. Then next we are going to see the central air conditioning system. The central air conditioning system is adopted for large buildings, store, hotels, hospitals, cinema theatre, etc. This system is used only for heavy loads about 20 ton or more. The various components of central air conditioning system are not assembled at the factory inside. They are assembled at site in control room from where conditioned air is distributed to the record place through the ductwork. The ductwork should be carefully designed, the fabricating and erected. This is the first image shows the cooling coil is there. So cooling coil is represented. In this central air conditioning system, we have two major types. One is summer air condition, another one is winter air condition. The first image shows the summer air condition. It consists of the air damper and air filter, cooling coil and pump and water eliminator. These are the important components in the air compression. That is a summer air conditioning system. This system is used in the summer air conditioning applications. In this system, air is cooled and generally dehumidified. The schematic diagram is shown in figure. The outside air flows through the damper and mixes up with the recirculating air which is obtained from the air conditioned space. The mixed air passes through a filter remove dirty dust and other impurities. The air now passes through the cooling coil. The coil has the temperature much less than the record dry bulb temperature of the air in the conditioned space. The cooled air passes through the performed members and loses its moisture in the condenser from which is collected in a sump. Air now passes through the heating coil which heated up the air slightly in order to bring out the record dry bulb temperature and relative humidity. Now conditioned air passes through conditioned space by a fan. From the conditioned space, the part of air is exhausted to atmosphere by exhaust fan or ventilation. The remaining part of the used air or recirculated air is again conditioned as shown in the figure. The outside air is sucked and made to fix with the recirculating air in order to make up the loss of conditions or used air through the exhaust fan or ventilation from the conditioned space. This is the summer air condition. The second image shows the winter air conditioning system. In winter air conditioning, the air is heated, which is generally followed by humidification. The symmetric arrangement of the figure is there. You can see this figure. The outside air flows through a damper and mixture of the recirculating air. The mixed air passes through the filter to remove dirty dust and other impurities. The air now passes through the preheat coil in order to prevent the possible freezing of water and to control the evaporation of water in the humidifier. After that, the air is made to pass through the reheat coil to bring out the air the desirable dry bulb temperature. Now the conditioned air is supplied to the conditioned space by a fan. From the conditioned space, a part of used air is exhausted to atmosphere by the exhaust fan or ventilator. The remaining part of the used air is again conditions. The outside air is sucked and made to mix with the recirculating air in order to make up the loss of conditions air through the exhaust fan or ventilation from the conditioned space. Then next we are going to see the comparison between the unitary type and central type. Unitary type means the capital cost is high, then central means capital cost is low. Then factory assembled, then here assembled at site. Location in the space to be conditioned. Here the located away from the conditioned space. This is smaller capacity unit. This is larger capacity. Unitary means no need of ductwork. Here central means extensive ductwork is essential. Then unitary means failure in the system will affect one room only. This will affect all the rooms. Installation charges are less. A central unit much higher. Thank you.